Good morning, student. I am Mr. A. Shukla and I will be taking polynomial part 1 for you all today. Polynomials for you. The first part in this will be taking the introduction for the polynomials, then the polynomial in 2 and 3 variables and degree of polynomial, representations and value, zero and root of polynomial, remainder theorem, divisions, factorization of polynomial, factor theorem, factorizing a cubical polynomial and a small exercise. Now first of all, the polynomials. A polynomial consists of one or more terms. So to understand polynomials, we must first understand what is a term. Now the term is the product of integer and a literal or alphabet. The example is 3 into a is equal to 3a. The number is always written first followed by the alphabet, or minus 4 into y is equal to minus 4y, and the power on the literal can be any whole number. 0, as it is anything raised to power 0 is 1, so it can be any natural number from 1 to infinity. Then so the definition of polynomial comes to be: a polynomial is a collection of terms separated by positive or negative sign. Now a polynomial is called monomial if it contains only one term, and if it contains two terms it is known as binomial. If it contains three terms it is known as trinomial, and if more than four terms then it is called as polynomial. Then now coming to the polynomial in 2 and 3 variables and the degree of polynomial. Now the above examples, if you have seen carefully, they were of only one variable, that was x, so that is polynomial in one variable. We can also have polynomial in two variables. In this case we can see that it is two variable x and y. It can be of any type. The example over here is 3x square y plus 4xy square plus 6xy minus 4x minus 3y. Then the polynomial can also be in three variables. That is, as shown in this example, it is 4xy plus 3x plus 6y minus 2z plus 5. We'll be only doing in this up till three variables, but in this lecture we will be only doing for one variable. Now the degree of polynomial. The highest power of any term is called the degree of polynomial. Example, 2x plus 6. Since the degree of x, the power of x is 1, so the degree is 1. That's only since it contains two terms and only one is having the literal, and the power of literal is 1, so therefore the degree is 1. In the second example you can see it is 6x raised to power 5 plus 3x raised to power 4 plus 8x cube plus 2x square plus 11x plus 3. In this you can clearly see that 6 raised to power 5 is the term containing the highest power, so the power of x is 5, so degree is 5. And one more thing I want to clarify in this, that x raised to power 5 has got a coefficient 6, and similarly the coefficient of x square is 2. So any number that is multiplied to the literal is the coefficient of that number. Now representation and value. Now a polynomial can be represented as px, in bracket we write the x, where x is a variable. Whatever is in the bracket is a variable, so it can be written as px, gx, fx, etc. Now in this example, if px is equal to 2x square minus 7x plus 3, and if we put the value of x equal to 2, so we are supposed to write p2, or if you put p3, so whatever value we are putting for x we are supposed to write in the bracket with the p, and then wherever we find x in the equation we put the value, whatever we are putting the value for x. So in this we have put the value of x in the first case as 2, so it becomes 2 into the dot is actually multiplication sign, so 2 into 2 square minus 7 into 2 plus 5. This is equal to 8 minus 14 plus 5. So this is equal to minus 1. And in the second case, we are putting the value of x is equal to 3. So it is 2 into 3 square minus 7 into 3 plus 5. So it is 18 minus 21 plus 5, which is equal to 2. Now for finding the zeros and the root of the polynomial. So in this, I'm taking the same above example. So in this example, if I put x is equal to 1, so it becomes 2 into 1 square minus 7 into 1 plus 5, which is equal to 2 minus 7 plus 5, which is equal to 0. So any value of x, if it makes px equal to 0, then that value is 0 of the polynomial. In this case, the example that I have shown, in 1, if you put x is equal to 1, it becomes polynomial px becomes equal to 0. So 1 is the 0 of the polynomial. And since we put x is equal to 1, this implies x minus 1 is equal to 0. Therefore, x minus 1 is the root of the polynomial px, or it can be also called as a factor of the polynomial. Now coming to the remainder theorem. Now this is the basic that I'm going to tell you, and everybody knows this. Now if in this example, if 283 is to be divided by 5, please don't go to the quotient 47. I'm doing step by step, so that's why I cannot show you. But if I divide 238 by 5, then first it goes by 4 times. Then I have to change the sign. We have to change the sign. Since 20 was positive, we have made it negative. So the remainder, after subtraction, we get 3 and 2 is carried down. 8 is carried down. Then it goes again by 7 times, again changing the sign, and after subtraction we get 3. So 5 is the divisor, 238 is the dividend, 47 is the quotient, and 3 is the remainder. So the remainder theorem says that dividend is equal to divisor into quotient plus remainder. While doing the factorization theorem, we will be seeing this. Then for the polynomial also we follow the same rule. Now we will see the division of the polynomial with one single variable. Now in this case it is 3x cubed minus 4x square minus 3x minus 1. It is to be divided by x. So you can see that the individual term is divided by x. So after dividing the individual term by x, we get 3x square minus 4x minus 3 minus 1 by x. Now the same dividend is divided by x minus 1 in the second case. So we are supposed to arrange the dividend into the ascending order, the highest value first, followed by the smaller values, and you can see the highest is 3x cube. Now to convert the divisor x minus 1 into 3x cube, we are supposed to multiply it by 3x square. So the first term, you can see it is 3x square. So if x minus 1 is multiplied by 3x square, we get plus 3x cube minus 3x square. So the sign which is on the top is actually the actual sign which is coming, and we are supposed to change the sign. So after whatever change of sign is there, that is written at the bottom. So the first term, that is 3x cube, get cancelled, and the second term we get only minus x square. So we take down the next term, that is minus 3x. Now we are supposed to get minus x square. So we multiply the divisor with minus x. Even the sign should be the same as in the above. So we multiply it by minus x. So we get minus x square plus x. After changing the sign, the first term gets cancelled, and we are having minus 4x minus 1. Minus 1 we are taking from the top. Now since the first term is minus 4x We are supposed to multiply the divisor by -4, so it becomes -4x plus 4, and after changing the sign we get a remainder of -5. Now factorization of a polynomial. We can factorize. In this we will be taking only the quadratic equation, that is a trinomial in one variable with a degree 2. This is known as a quadratic equation, and the general form of the quadratic equation is ax squared plus bx plus c is equal to 0, where a, b, c are integers. There are two methods of factorizing. First is the splitting the middle term, and the second is factor theorem. In splitting the middle term, we are supposed to, the middle term is bx, and bx is to be split into two parts. In this we are taking b1 and b2, so it is b1x and b2x, such that b1x plus b2x is equal to b, and the product, that is the multiplication of b1x into b2x, should be equal to ax square into c, as it is shown. Now it will be more clear with the example. This example is, in this we are taking the quadratic equation as 6x square plus 7x plus 5. In this A is 6 and C is 5 and B is 17. So bx and b1x and b2x can be taken as 15x plus 2x, because since 15x plus 2x, 15x into 2x is equal to 30x, which is equal to ax square into c. You can see it is also equal to 30x, and b1x plus b2x is equal to 17x. So in this 15x plus 2x is equal to 17x. So after breaking the middle term, you can very well see that 6x square plus 17x plus 5, so 17x is broken. It is being broken into 15x plus 2x. So in this, the first two terms, that is 6x square plus 15x, 3x is common, so 3x we can take it out, so we are left with 2x plus 5, and the second term 1 is common, so which is not to be shown outside, or we can, if you want, you can show it. So after taking the common, we get 2x plus 5 into 3x plus 1. This is the way of factorizing by splitting the middle term. Now coming to the factor theorem. First we will be taking the general quadratic equation, that is ax square plus bx plus c is equal to 0, and we will convert it into the form of x square plus bx by a plus c by a. We will take a outside, then this becomes equal to a p plus x and p plus q, where p and q are actually the roots or the zeros of the polynomial, and since p and q don't have any variable attached to them, so they are p into q is equal to c by a. That is the third constant term. Now this will be more clear once I take the example. Now in this, the example is z square minus 5z plus 6, and in this I am taking minus a and minus b as the zeros, so z minus a into z minus b is equal to z square minus 5z plus c plus 6. So minus a into minus b is equal to 6, and the factors of 6 are plus minus 1, plus minus 2, plus minus 3 and plus minus 6. Now if we put the factors one by one, so we can see that p1, if we put p is equal to 1, we get 1 square minus 5 into 1 plus 6, which is equal to 1 minus 5 plus 6, which is equal to 2. If we put p is equal to 2, we get p 2 square minus 5 into 2 plus 6, which is equal to 4 minus 10 plus 6, which is equal to 0. And if we put p is equal to 3, sorry, x is equal to 3, we get x cube minus 5 into 3 plus 6, which is equal to 9, minus 15 plus 6 equal to 0. Therefore we get two zeros, and the zeros are z is equal to 2 and z is equal to 3. These are the zeros of the polynomial, or z minus 2 and z minus 3 are the factors of the equation z square minus 5z plus 6. Now factorizing a cubical polynomial. Now a cubical polynomial is a polynomial which is having the value, which is having the degree 3. Okay, now the example is over here. It is x cube plus 13x square plus 32x plus 20, and since the constant term is 20, we are supposed to find the factors of 20, and the factors of 20 are plus minus 1, plus minus 2, plus minus 5, plus minus 6, plus minus 10, and plus minus 20. One thing that you are supposed to ensure that the factors of all the composite numbers will be in even terms. That is, all the factors will be actually in pair. Now if suppose 20 into 1, so that is 2 into 1, it's in pair, then 2 into 10, it's in pair 20, and 4 into 5, that's again a pair. So they will always be in pair, except for the squares. In the case of squares, it will be odd numbered, but other composite numbers will have factors in pairs. Now after that, now we are all the factors are there. Now it is a trial and error method in which we are supposed to put the values of x, and for whichever values of that we put for x from these factors, if any value is equal to 0, then that we are supposed to take. So in this we have tried. The first one is minus 1. If you put p minus 1, then the whole equation becomes equal to 0. As you can see, that is minus 1 cube plus 13 into minus 1 is square plus 13 2 into minus 1 plus 20. This is equal to 1 plus 13 minus 32 plus 20 equal to 0. So this is minus 1 is the 0. So therefore x is equal to minus 1 or x plus 1. If we transpond minus 1 to the left side, it becomes x plus 1 is a factor of the polynomial px. Now since this is a factor, we are supposed to divide the complete equation x cube plus 13 x square plus 32 plus 20 by x plus 1. So on dividing, we get a quotient. Remainder will be 0 because it's a factor, and the quotient is x square plus 12x plus 20. Now again, this is a quadratic equation, and by splitting the middle term is split into 10x plus 2x, and so we finally get the factors of x cube plus 13x square plus 32x plus 20 equal to x plus 1, x plus 2, and x plus 10. Coming to the exercise 3. In the first one, you are supposed to identify which of the following are polynomials and which are not. The first one is 4x square plus 3x plus 5. The second is x square plus under root 3. The third is 6 under root x plus 4. And the fourth is x raised to power 4 plus y raised to power 6 plus z cube. Now the second is degree. You are supposed to find the degree of the polynomial. The first one is x raised to power 5 plus 4x cube plus 3x square plus 6. Second is x square minus 4. Third is 6y minus 7. And fourth is 2x cube plus 6 square plus 4x plus 3. Now the third is you are supposed to find the value of the polynomial px, which is equal to 3x square plus 8x minus 16 when x is equal to 0, x is equal to minus 1, and x is equal to 2. The fourth is related to the third one, in which you are supposed to find the value of p minus 1 plus p2 upon p0. Now this is all the type of problems that will be coming directly. You don't in the examination, it is very important from the examination point of view. Now the fifth one is factorizing. The first part is x square minus x minus 6. The second is x square minus 7x minus 12. And the last is factorizing a quadratic equation, cubical equation, which is x cube plus x square minus 14x minus 24. Good luck.